Hi everyone, and welcome back to my lecture series in differential equations. In our previous topic, we learned how to calculate the growth of population or the decay of radioactive substances using the law of natural growth or natural decay, which is an exponential model. However, real-life population does not really increase forever exponentially. Possibly, the population growth is exponential, but that is only at the start, when the population is still young. And due to some constraints, the population will approach a certain maximum value. The limiting factors include food, living spaces, and the availability of natural resources. This model of population growth that considers these factors is called the logistic differential equation. Okay? And that is our topic in this episode. So, from the logistic differential equation, we will obtain its solution, which is considered as the logistic growth model. Aside from population dynamics, the logistic model is also very useful in predicting the spread of diseases. In fact, many countries have already used the logistic model or some modified versions of it in predicting the outbreak of the COVID-19 pandemic. So now, let's begin our study of the logistic differential equation. In my introduction, I have mentioned about a certain maximum value of the population. So this maximum value is the limiting population in a certain region, which is called the carrying capacity, and we denote it using the letter M. So in problem solving, this M is a constant which refers to the maximum value of the population, or what we call the limiting value of the population. And in the logistic model, the population P is proportional not only to the present population. So we may recall that in the natural growth model, the population growth is proportional only to the present population. On the contrary, sa logistic model, the population is proportional also to the present population, but in addition to that, it's also proportional to the remaining tolerable population. So ano ang ibig sabihin nitong remaining tolerable population? So if M is the maximum value of the population and P is the present value of the population, ilan pa yung population na tolerable bago marating yung maximum? So kung ang M ay maximum at ang present value ng population ay P, then yung pwede pa nating idagdag na population, which I call the tolerable value of the population, is M minus P. So from this, we can create a differential equation. So the population growth is proportional. Okay, so dapat ito ay growth, no? Population growth is proportional to both the present population, which is P, and the remaining tolerable population. So kung gagawan ko yan ng differential equation, this dP over dt is the population growth. And it is proportional to P, the present population, which is similar to the exponential model. But in addition to that, ito ngayon yung pagbabago na nangyari dyan, no? dP over dt, or this population growth, is also proportional to the remaining tolerable population, no? Yan yung amount ng population na pwede pa nating idagdag bago marating yung maximum value. Okay, so we now have what we call the logistic differential equation. Okay, so by inspection, we can say that this equation is nonlinear. Why? Because if we multiply Kp with this term, we will get P squared, which is a nonlinear function of the dependent variable P. So this equation is non-linear. This model of population growth was proposed by the Dutch mathematician Pierre-François Verhulst in the year 1838 as a model for world population growth. And also, if you will inspect this logistic differential equation, it can be said that this is a Bernoulli type of differential equation. Since we already know how to solve Bernoulli differential equations, then it would be a challenge or an exercise for you to get the solution of the logistic differential equation for you to derive what we call the logistic model of population growth. So let us rewrite the logistic differential equation. dP over dt is equal to Kp times m minus p. Diba? Yan yung logistic differential equation. So, kung i-distribute ko ito at i-multiply, I will get this. dP over dt is equal to Kmp minus Kp squared. And as I have said kanina, yan ay nonlinear because of the term p squared. And at the same time, this is a Bernoulli type of differential equation. Now, we will make some changes in this equation by letting this term Km be equal to a certain parameter R. So, we will replace this Km with R. At yung R na yan ang tinatawag na intrinsic growth rate. Okay? So, dP over dt will become Rp minus itong K naman na ito ay magiging equal sa R over M. No? So, we will have dP over dt equals R times P minus yung K na equal sa R over M times P squared. So, eto na siya ngayon. So, bakit natin ito ginawang ganyan? No? Because we want to use the parameter R, which I have mentioned, is called the intrinsic growth rate. And para rin maging separable yung ating equation. So, ginawa natin ang paraan para siya ay masolve mo in the easiest possible way kasi pwede mo siyang gawing separable. Paano? Okay. So, we may notice here that this term Rp is a common factor. Ayan, o may Rp dito and at the same time, meron ka ring Rp dun sa pangalawang term. And because it's a common factor, pwede natin yung i-rewrite in its factored form. Okay? So we have dP over dt is equal to Rp times the quantity 1 minus P over M. So once again here, R is called the intrinsic growth rate. And M is another constant which is called the carrying capacity. So here, our dependent variable is P, which represents the population. Now, you may also notice that on the right-hand side of the equation, the only variable present is P. So here, we have a derivative that is purely in terms of the dependent variable P. Such an equation is called an autonomous equation. Yung ating derivative explicitly is a function only of the dependent variable. Wala kang makikita ditong time na involved. Now consider the situation when P is still very small. Okay? So, alam natin itong M ang maximum capacity. So, ina-assume natin malaking value ito. Kapag yung P ay maliit pa ang value, kasi sa simula pa lang no? So, this term will be negligible, right? Kasi maliit pa ang value ng P at napakalaki ng value ng M. Kasi yun ang carrying capacity or maximum capacity ng population. So in that case, yung P over M ay magiging negligible. At pag yan ay naging negligible, ang matitira na lang is yung dP over dt is Rp. At kung mapapansin mo, yan yung differential equation natin for exponential model. Diba? So that means, kapag maliit pa pala ang value ng P, yun palang model natin ay pwede nating i-approximate as an exponential model kasi ang matitira na lang is dP over dt is equal to Rp. Yes. So that is an important conclusion here. Kagaya ng nabanggit ko kanina doon sa introduction, ang population ay hindi nag-increase exponentially forever. No? However, sa simula, posibleng ito ay exponential. Ayun. No? So mathematically, nakita na natin na sa simula pala, itong logistic growth model, pwede nating i-approximate din as an exponential. No? Again, yun ay sa simula lamang, in the early years. Okay? Pero habang tumatagal, yung population natin ay may i-approach na maximum value. At ito yung M. Hindi siya mag-i-increase forever exponentially. So, kapag na-solve natin ang differential equation na ito, dapat Kapag ang t ay nag-approach sa infinity, dapat ang makukuha nating sagot ay equal sa m. Bakit? Kasi yun yung ina-approach na value ng population habang tumatagal. Okay? Titingnan natin yan later. Puprove natin yan. Another important thing to note in this differential equation is when dp over dt becomes 0. Kailan ba magzi-0 ang dp over dt? Ano ang ibig sabihin kapag ang dp over dt ay 0? Diba? So, ang dp over dt ay population growth. Growth rate. Okay. So, kung yan ang population growth rate at yan ay 0, ibig sabihin, hindi nag-i-increase ang population or hindi rin ito nagdi-decrease. So, in that case, yung makukuha nating solution when dp over dt is equal to 0, ang tinatawag natin na equilibrium solutions. Okay, so by inspection, malalaman natin yan eh. No? Kailan ba magzi-0 ang dp over dt? Kapag itong p na ito ay nag-0. Okay? And ito pang term na ito kasi product sila. Kailan magsi-0 ang term na ito? Okay, so here we have 1 minus p over m. So if this p becomes equal to m, then this term becomes 1 and 1 minus 1 becomes 0, which would yield dp over dt equal to 0. So that is another solution. Aside from p is equal to 0, when p is equal to m, this dp over dt will also become 0. And these two values of p is equal to 0 and p is equal to m, these are what we call the equilibrium solutions of our logistic differential equation. Now, paano natin ito isosolve? Okay, so kagaya ng nabanggit ko kanina, ito ay separable na. Itong p at saka itong factor na 1 minus p over m, they are all functions of the dependent variable p. That's why, pwede ko siyang gawing denominator ng dp. At itong dt naman, gawin kong multiplier ng r. So, magiging ganito siya. dp over p times 1 minus p over m equals r dt. Ayan. So, masosolve mo na siya ngayon using the known methods of integration. Okay? But that is not our main concern in this topic. Okay? Marunong ka na namang mag-solve ng differential equation. Marunong ka na mag-integrate. So, I think that could be left as an exercise for you. Okay? Now, kapag sinolve natin itong differential equation na ito, nagagawin mo after mong manood ng video na to, ano? Kasi exercise mo yon, no? Ito dapat yung makuha mong solution. The solution of the logistic differential equation is this. And this is what we call the logistic growth model. So the population P is equal to this M, which is the carrying capacity or the limiting value of the population divided by 1 plus a certain arbitrary constant A, E to the negative R, T. So, I'm sorry, hindi na pala siya arbitrary. Bakit? Kasi po ito ay solution ng initial value problem. Kaya siya ay particular solution na. So, dito ang ating condition is P naught or PO. Ano ba yung P naught? Mani. Because it's P naught. Yan ang initial value ng population na gagamitin natin para makompute yung value ng A. Ano? So, yung A na yan ay equal sa M over PO then minus 1. So here, this A is the carrying capacity divided by the initial value of the population minus 1. Remember, this PO is the initial value of the population. Kapag itong time na ito ay nag-approach sa infinity kasi tumatagal lang tumatagal, ano ang mangyayari sa term na ito? Because this is a decaying exponential. As t increases, this term will decrease and approach 0. If that happens, what will remain is just m over 1 or simply m. Kaya nga natin tinawag iyan na maximum value ng population. Kasi po habang tumatagal, patagal ng patagal, yung P natin ay i-approach ang value na ito. Okay? Hindi ba? Ang galing. Ngayon, ano kaya ang itsura ng graph ng solution nito? So, ito yung solution ng DE. Di ba? Yan yung model natin. Ano ang itsura ng graph? So, yung graph niyan ay nakadepende ang itsura sa value ng M at saka sa value ng PO. Iba-iba ang value ng M at ng PO. Iba-iba yung itsura ng graph. So, let us have some examples. Here, notice that the initial value of P is greater than the maximum value. Yan. Kapag initially ang P ay mas malaki pa sa carrying capacity, ano ang mangyayari sa population? Yan ay liliit. At again, i-approach niya yung carrying capacity. 'Di ba? So, paano natin yan mapuprove mathematically? Bakit nagkaganon? Kasi po, kapag itong P ay greater than M, itong term na ito magne-negative. So, pag yan ay nag-negative, yan ay kagaya ng model para sa isang decaying exponential. Now, kapag ka naman ang initial value ng population ay less than M, kagaya nito, dito, ayan. So, initially, mag-i-increase siya exponentially, and then, habang tumatagal, hindi na siya exponential. It will approach the maximum value M. So, dito, mas mataas yung initial value niya. Dito, mas mataas pa. And here, we have an even higher initial value of P. But in all cases, habang tumatagal, anuman ang initial value ng population, they will all approach the equilibrium solution, which is P is equal to M. Why? Because it is the maximum or the limiting value of the population. Okay, so this is now the logistic growth model which we will use in the succeeding problems. Kaya dapat kabisado mo ang formula na ito. Okay, so once again, let us recite the logistic growth model. P is equal to M divided by 1 plus AE raised to negative RT. So here, P is the population, M is the carrying capacity, A is a constant equal to M over P naught minus 1, and R is called the intrinsic growth rate. Okay? So, to put this logistic growth model into action, let us solve some sample problems. Sample number 1, suppose a population grows according to a logistic model with initial population 1,000. Okay, so isulat na agad natin yan, no? Ang initial population daw ay 1,000. Tapos, ang carrying capacity. So, we have M equal to 10,000. If the population grows to 2,500 after 1 year, so that means P after 1 year, P1 equals 2,500. So, ang sabi sa letter A, formulate the differential equation that models the population. So, remember, the logistic differential equation, so that's dP over dt is equal to Kmp minus Kp squared. Pero dito wala tayong R. So kung gagamitan natin yan ng R, dP over dt equals Rp minus R over M times P squared. Okay, so ito na yung differential equation natin. However, hindi pa natin alam kung ano ang value ng R, although alam na natin yung value ng M. Okay? So for letter B, what is the value of the intrinsic growth rate? So remember that the intrinsic growth rate is R. Okay, and since we know the value of P1, we can use this to get the value of R. So remember that the solution to the logistic differential equation is this. We have M over 1 plus A e to the negative R times T. So from this, we can solve for A from the given data. A equals, remember that A is the maximum capacity, 10,000, over the initial population, 1,000 minus 1. Okay, so without any calculator, madali lang naman yan. 10,000 divided by 1,000 is 10 minus 1. That is 9. Okay, so we now have the value of A. If we use T equals 1, no, na ang P ay equals sa 2,500, okay, makukompute ko na ngayon ang value ng R. So, palitan ko lang yung P dito ng 2,500 equals yung M na 10,000 divided by 1 plus A, which is equal to 9, e to the negative R, kung saan yung R ay hindi natin alam, at yung T ay equal sa 1 kasi after 1 year. So, hindi ko na ilalagay dun yung 1. So, here, the only unknown quantity is R. So, pwede na natin siyang isolve ngayon. 'Di ba? Pwede na tayong mag-shift solve. Okay? Para madali. So, input lang natin yan sa calcu. 2,500 alpha equals fraction sign 10 exponent 3 kasi 10,000 divided by 1 plus 9 alpha e raised to negative alpha x. Yung x doon, yun yung r na hinahanap natin. And then shift, solve. Okay. So, dito maglalagay tayo ng estimated value ng r na alam naman natin ay positive dapat, no? Kasi negative na siya dito eh. Positive but less than 1. So, 0.0123. Halimbawa lang, di ba? Okay, and then after that, press equal sign para mag-iterate yung calcu mo. Ayan. So, meron tayo ditong nakuha na value na r is equal to 1.0986. Okay? So, sulat natin. R is 1.0986. Okay? So, para hindi na natin yan isusulat from time to time, isave natin ang kanyang value. Shift, store, A. Ayan. Okay, so meron na tayong value ngayon ng R. Pwede mo na siyang i-substitute dito para makumpleto mo yung iyong differential equation. And at the same time, meron na tayong intrinsic growth rate. So sige, isulat natin yung kumpletong differential equation. Gawin natin kulay yellow. dp over dt is equal to, ito yon, 1.0986 times p minus r over m. Sa calculator natin, yung r natin is yung a, tapos yung m natin is 10,000 exponent 3. Yan. So, we have 1.0986 times 10 to the negative 4. Diba? Or 0.0001096. Ayan. Times p squared. Okay. So, this is now our differential equation. Kung gusto mo, common factor pa rin siya. Diba? Now, after that, after having our intrinsic growth rate and our complete differential equation, let us find another quantity. Ano ang population after another 3 years? So, kasi kanina, after 1 year, 2,500. After 1 year yon. Eh, ang sabi niya, after another 3 years. So, that means dito, ang time na involved ay 1 plus 3. So, that means 4. Ano? So, when t is equal to 4, hinahanap ano naman ang population. So, that means ang hinahanap natin ay P4. Sulat natin dito. P sub 4 is equal to the carrying capacity, which is 10 times 10 raised to 3 divided by 1 plus 9 e to the negative r times yung t na equal sa 4. 'Di ba? Itong r naman na to nakasave yan sa calculator natin. So, yung P4, pwede na natin ngayong makuha. Kapag tayo ay nag-calcu, tanggalin ko lang yan. So, we have 10 exponent 3 divided by 1 plus 9 alpha e raised to negative alpha a, kasi nandun yung r, times 4 equals. Ayan. So, after 4 years pala, or after another 3 years, ang population is exactly 9,000. O, diba? Ang dali lang? So, kailangan lang guys, kabisado natin yung logistic differential equation and at the same time, kabisado mo rin yung kanyang solution na tinatawag nating logistic growth model. Okay? So, once again, isulat natin ha. Ano nga yung logistic differential equation? That's dp over dt is equal to kp times m minus p. Na kapag yan ay iyong sinolve, ang makukuha mong solution is P equals M divided by 1 plus A e to the negative RT, kung saan yung A ay equal sa, remember, that's M over PO minus 1. Okay, so yung R dito ay equal sa K times M. At yung R na yan ang tinatawag natin na intrinsic growth rate. Kasi dito walang R sa differential equation mo. Pero dito may R. So ito yung relationship ngayon or equation na nagre-relate doon sa R at sa K. O diba? Madali lang. Now, let us solve another problem. Nabanggit ko kanina na bukod sa pagpipredict ng population growth, ginagamit din ang logistic differential equation sa pagpe-predict ng outbreak ng mga diseases, 'di ba? And kagaya rin ng nabanggit ko kanina, itong logistic model ay ginamit ng ibang bansa. Maraming bansa na ang gumamit niyan sa pag-aaral nila ng pagkalat ng coronavirus disease or ng COVID-19. That is why in the next example, we will use this logistic model to predict COVID-19. COVID-19 is spreading through a city of 160,000 people who take no precautions. Okay, so that means dun sa city na nabanggit dito, walang sinusunod ng mga health protocols, walang social distancing, walang wearing of face masks, etc. No? Walang mga quarantine. Okay? So, kung ganito karami yung tao doon sa city na ito, darating yung time na silang lahat ma-infect. Bakit? Kasi nga walang precautionary measures. Walang health protocols, walang social distancing and wearing of face masks. So if that is the case, then we can use the logistic model. Bakit? Kasi nga po, yung logistic model, mayroon dong maximum capacity. Di ba? So kung dito sa problem na ito ay wala daw sinusunod na precautions ang mga tao, darating sa time na lahat sila may infect kasi hindi sila nag-iingat, 'di ba? Ganon ang logistic model. Okay? And kung i-assume natin na logistic growth yung masusunod dito, then itong 160,000 na ito, which is yun ang population ng city, yan ang maximum capacity, no? Kasi darating ang time lahat ng tao mai-infect na. So yung M natin ay 160,000. Okay? So dito, yung P ay hindi yung population, but rather, yung number of infected individuals. Okay? So initially daw, 80 people ang infected. So, if we let P be equal to the number of infected people, initially, ilan daw ang na-infect? 80. Ayan. And it was found that 1,000 people were infected after 12 weeks. Shit, no? After 12 weeks, umabot na sa 1,000 ang may COVID. Bilis na. Bakit? Kasi nga, walang precautionary measures. So, how long will it take for half of the population to be infected? Ayan. So, kung half ng population ay 80,000 yan, kailan mangyayari na mai-infect na ang kalahati ng mga tao sa city na ito? Okay? So, let us solve the problem. So, since the model that we will use is the logistic model, isulat natin yan. P is equal to M, which is 160,000, right? Divided by 1 plus A, e to the negative R times T. Kung saan ang A ay pwede nating makompute. Ano ang formula ng A? That's the maximum capacity, 160,000, divided by PO, which is 80 minus 1. Okay? 160,000 divided by 80, that will give us 2,000. 2,000 minus 1 is, Diyos ko, 1999. Nakakaloka. 1999. Parang taon lang, di ba? So now I can rewrite this P as P equals 160,000 over 1 plus A, which is 1999. Siguro yung iba pinanganak na sa inyo nun. Negative R times T. Ayan. So, dito, hindi pa natin alam yung R. Pero given yung value ng P after 12 weeks. So, dito pala ang time ay naka-weeks. Okay? So, if I make this T equal to 12, the value of P is 1,000. No? Pwede na tayo mag-shift solve doon para makompute natin ang value ng R. Okay? So, we have 1,000 equals 160,000 divided by 1 plus 1999 e to the negative R times 12. Okay? So, kung isi-shift solve natin ang R, magiging ano siya? 10 equals fraction sign 160 exponent 3 divided by 1 plus 1999 e raised to negative 12 alpha x. Kung saan yung x ay magsisilbing R. O, diba? And then shift, solve. Solve for x. Ano yung R? Gamit ulit tayo ng assumption, 0.0123. And then equals. Ayan. So, may nakuha tayong value na 0.211 approximately. No? So, R is 0.211 approximately. Pero, sa calculator, isi-save natin yan. Shift, mali. Shift, store A. Ayan. Okay, nakasave na siya ngayon sa A. Ang sabi dyan, how long will it take for half of the population to be infected? So, kung half, edi ang P doon is kalahati or 0.5 of M equals yung population na M divided by 1 plus 1999e to the negative R times T. These two M's will cancel. Alam natin yung value ng R, so pwede nating makompute yung value ng T. Ano? Para madali, shift solve na lang ulit. 'Di ba? Okay. So, pag ito, inilagay ko doon, at ito nilagay ko dito, magiging 1 over 0.5 is 2. 'Di ba? Ayan, 2 alpha equals, tapos ito ilalagay ko na lang dito sa taas. So, 1 plus 1999 e raised to negative R times T. Yung R ay nasa A. Alpha A times alpha X. Ayan. Pwede na tayo mag-shift solve. Shift, solve. Okay. Ito yung A. Diba? I-equals mo lang yan. And then, for the value of X, kung saan dito ay time yun. Diba? Kasi kanina 12. So, dapat yung ilalagay nating value dito ay more than 12. Pagpalagay natin 20. Assuming lang, equals, ayan, nag-compute na siya, no? Ay, yung nakuha niyang sagot ay 36 weeks. Okay? Kung gagawin nating months yan, divided by 4. So, or approximately 9 months. Ayan. So, dun pala sa city na yan, kung hindi sila nagso-social distancing, walang quarantine, walang wearing of face mask, at walang mga health protocols, sa loob ng 36 weeks or 9 months, no, kalahati ng tao doon ay magiging infected. Okay? But that is not the actual case that we have in real life. Bakit? Because in real life, we do precautionary measures. No? Kaya posibleng itong logistic model ay accurate lamang sa simula. Kasi doon, nagsisimula pa lang ang outbreak. Diba? Pero habang tumatagal, yun yung sinasabi nila na magne-negative yung slope. So, let me show you the actual graph of this solution. No? Yung graph nito. Kung saan ang R ay 0.211. Ito siya. Ayan, no? So, habang tumatagal, dumarating tayo or ina-approach natin yung limiting value na 160,000. Ito yon. Pero sa tunay na buhay, dahil may social distancing, darating yung time na yun ay mag-decline. Okay? Magde-decline siya. Bababa. Okay? So, here are some of the data which were gathered in other countries. Ito yon. Ayan. Specifically sa China ito eh. And look, okay? Ito yung mga predictions nila. Nakamukha ng ating graph ng logistic model. Okay? And then eventually, nagkakaroon tayo ng negative slope na. Bakit? Kasi we implement health protocols. Okay? So this only shows that we can use this logistic model for predicting viral outbreaks. Kaso nga lamang, kapag nag-implement tayo ng mga health protocols, darating yung time na mababawasan na yung infected individuals at magne-negative na yung slope. Di ba? Ang saya? Na-feel nyo na naman yung inaaral nyong subject na differential equations ay napaka-relevant sa ating buhay. Okay? So, that would be all for our topic in today's episode. If you like this video and you think you learned from it, don't forget to hit the like button and subscribe to my YouTube channel. Okay? Bye! See you again in my next video.